So we are going to be sketching the graph of a derivative, or we're going to be sketching the graph of a function based on the derivative. Okay, so basically go either way. All right. Now, what we're going to do primarily is we're going to focus on the slope. Okay, because the slope of f is the y value for f prime. So the easy part is if we're given a function. So here we're given f of x, all right, and we want to graph f prime of x. Okay, so we want to convert this into f prime of x. All right, some key concepts we're going to need to take note of. One, max and mins. All right. When you have max and mins, this is where the derivative will cross the x-axis. Okay, f prime of x is equal to 0. So here we have a local max. We're going to put a value on the x-axis. Here we have a local min. We're going to put a value on the x-axis. All right, 2, increasing means f prime of x is positive. Decreasing means f prime of x is negative. So everywhere where it's increasing, the derivative should be above the x-axis. So here we are increasing. So all the way up to that point, I should be above the x-axis. Here we are decreasing. So we should be below the x-axis. Here we are increasing again. So above the x-axis. And there's the, again, approximate graph of our derivative. It does not have to be perfect. So again, graphing a derivative based on a function really isn't that bad. Okay. Now, things we also need to make note of, and I'll give you a second. Again, we have tons of time. It's a really short lesson. But there's things you need to make note of. When you take the derivative of a function, what happens to the power of the function? Decreases by 1. Right. Basically, every time you take the derivative, it decreases by 1. Okay. So, since we have how many turning points on our original function? So, how many turning points should we have on our derivative? 1. That's the same kind of concept. Okay. So, the idea here is 3, the derivative should decrease by 1 degree. Now, the problem that occurs with going the other way, taking the derivative and graphing the function, is this right here. And we kind of already talked about this. If we have f of x, I say kind of, we're talking about this. Again, I get this mixed up with BC all the time, so because we all teach the same stuff. So if we have x, 3x squared plus 2x, or just plus 2, okay? What is f prime of x? 6x, okay? If we have f of x is 3x squared minus 12,513, what is f prime of x? 6x. Do you see the issue that we have? Yeah, we don't know the y-intercept. We don't know the constant that's going to occur. So when you graph these and you check your answer on the answer key, as long as the basic shape is correct, you're fine. You may be down a bit or up a bit. Okay, it may be shifted down or up. That's okay, because again, we don't know where the original function starts at. Okay, so here's the idea. Now, we have to kind of think backwards about this. So there's still going to be some key aspects. Number one, f prime of x equals 0. These are local extrema. Okay, so we need to remember that a, if changing from positive to negative, f of x is a what? Positive negative local max. B, if changing from negative to positive, then f of x is a local min. So what that means is right here, and right here, we have 3 extrema. Okay. Here, f prime of x changes from negative to positive, so this is going to be a minimum. Here, f prime of x changes from positive to negative, so it's going to be a maximum. Here, f prime of x changes from negative to positive, so is another minimum. Two, when f prime of x equals 0, these are going to be, sorry, not, what am I meant to say? The max slash mins of f prime of x are points of inflection. So where it's going to change from concave up to concave down. F prime of x is greater than 0. F of x is increasing. When f prime of x is less than 0, f of x is decreasing. So again, you have to kind of think backwards of what we just did. One, in the previous question we answered, we went from 2 turning points to 1 turning point. Okay, well, we're going to go backwards now. So now we have 2 turning points. We should have how many turning points? 3. We should have 3 turning points. 1 more. All right, do we have all that written down? All right, give me a second.
You draw what Equifax might look like?
Yeah, we're going to do that in a second. Just to make sure I have this written down. Yeah. So we already said that right here and right here, these are going to be, I'm just going to put points of inflection. Right. Everywhere below, okay, everywhere down here, we are decreasing. Everywhere up here, we are increasing. So here's the thing. We don't know where my y-intercept is. Okay? So I can start way up top. I can start way in the bottom. Okay? As long as your basic shape is accurate. You should be okay. So, firstly, right now we are decreasing. So again, we are decreasing up to this point where I get a local min. Okay, so let's say I put a point here and decreasing up to that point. Once I reach that point, I turn and I start to increase. All right. Right here, I have a point of inflection to where my function changes from concave up. It's a little sharp here. There we go. So concave up to concave down. All right. Right here, I have a local max. Another point of inflection. Another minimum.
So,
It doesn't have to be perfect. Yours could be sharper. Yours could be way up here. Okay. It could be even very extreme. Okay. So that's the idea. Let me get rid of these other ones. So the idea that I need to see is that where these points cross, I need to see its corresponding minimum value, max value, minimum value. I need to see that. Okay, where I have points of inflections, I need to see it change from concave up to concave down. Again, concave down to concave up.
What can you describe what's concave up and concave down is?
Where the graph opens up, like concave up would be your x squared. Concave down would be your negative x squared.
Those not the thing with populations.
That's like
It's good experience.
from this way to this.
Where it changes from the graph opening upwards to opening downwards. Concave up means it opens up. Concave down means it opens down. So again, this is where the challenge is going to lie. Again, the point is where the local max and local mins are. I need to see those. Okay, those need to be accurate. Not their y values. Their y values don't need to be accurate, but the x values need to be accurate. Okay, where you have points inflections, those x values need to be accurate. Again, the y values can vary depending on where you start. All right. Questions, because that's it. All right. Yes.
5. Everything.
Oh,
That's Jake. You did not believe it's not me. There's your less.
Not for C. So, but I said, so this is really what this
Or is it?
is. When we get into it, is that, you know, right? What? It's.
Why are you thinking? Albert is on that.
real quick. This very last part where it said f prime of x is greater than 0, it's increasing, and prime of x less than 0 is decreasing. This is going to naturally occur if you get your local mins and local maxes correctly. Okay? Because right here, right here, okay, my function is below the x-axis. So this is where my original function will be decreasing. So that highlighted little green section is where f prime of x is below the x-axis, which means your original function should be decreasing up to that point. And it does that. Again, as long as you get your local max and local mins correct, that will automatically occur. So you don't really have to focus too much on that last part. It should just automatically match up if you do the rest of it correctly.
Sure.
So, anything else? All right. So you have the rest of class to get the homework done? I'll post the answer key again. Don't stress if you're not exactly like the answer key. Just focus on making sure your critical values are correct.
One.